Hello, chemistry students. Today I'm going to walk you through a little bit of how to work through this Mole Practice 2 worksheet. So the first thing to remember is that moles are the center of everything that we do. And we can convert from moles to particles, or we can convert from moles to grams. And to go from moles to grams, 1 mole equals the molar mass on the periodic table. And to convert from moles to particles, we use Avogadro's number, 6.022 times 10 to the 23rd. So in this first question, where it's asking how many molecules are there in 24 grams of FeF3, we are starting with 24 grams of FeF3. So to set up our conversions, we're starting with grams and we're trying to find molecules. This is going to be 2 steps. So the first step, since we start with grams, grams will go on the bottom and moles will go on top. And the relationship is that 1 mole equals the mass of iron, which is 55.85, plus the mass of fluorine, 19, times 3. That's 112.85. So this would just get us from grams to moles, but the problem wants us to find molecules. So we'll tack on our second conversion, and since moles is on top here, it moves to the bottom of our conversion, and we'll put molecules on top. And the relationship is that there are 6.022 times 10 to the 23rd particles in a mole. So then we carefully put this in our calculator. 24 times 1 over 112.85 times 6.022 times 10 to the 23rd, use the E23, over 1 equals 1.28 times 10 to the 23rd. Don't forget the times 10 to the 23rd. That makes a huge difference in your answer. Problem number 2 works exactly the same way. Problem numbers 3 and 4 are pretty much the exact opposite. So let's take a look at problem number 4. If we're starting with 7.4 times 10 to the 23rd molecules of silver nitrate, and we're trying to go from molecules to grams, this is going to be a 2-step conversion where we go from molecules to moles, and then the second step will take us from moles to what we're trying to find, grams. And the relationship between molecules and moles is that 1 mole is 6.022 times 10 to the 23rd molecules, and from moles to grams, 1 mole equals the mass of silver, which is 107.87, plus the mass of nitrogen, plus the mass of oxygen times 3, so 169.88. And this is set up so that our units of molecules cancel out and our units of moles will cancel out, leaving us with grams as our final answer. Just like up here, grams cancel and moles cancel, leaving us with molecules. So we plug all of this into our calculator. 7.4 times 10 to the 23rd times 1 over 6.022 times 10 to the 23rd times 169.88 over 1 equals 208.75 grams. So those problems, 3 and 4, work pretty similar. For problem number 5, if we're just going from moles to grams, so in problem number 5, we're starting with 11.9 moles, and we're trying to go from moles to grams. It's just a one-step conversion. And we're working with chromium. Well, 1 mole of chromium is 51.99 grams. So we just do 11.9 times 51.99 over 1. We get 618.68 grams of chromium, because we set it up so that our units of moles cancel. So that's how we do those problems. And then we have the percent composition. Let me just walk you through number 9. We're trying to find the percent composition of CaCO3. Well, we need to first find the molar mass of the compound. So we take the mass of calcium plus the mass of carbon plus the mass of oxygen times 3, which is 100.09. Then we can find the percent calcium, the percent carbon, and the percent oxygen. So for the percent calcium, we take the mass of calcium divided by the whole mass times 100. For carbon, we take the mass of carbon divided by the mass of the whole thing times 100. And for the mass of oxygen, we take the mass of oxygen times 3, because there are 3 oxygens, over 100.09 times 100, and see what we get. So we take this one, we get 40.04%. Then we get 12%. We round off to 2 decimal places, and we got 47.96% oxygen. And all of those percents add up to 100%. So I hope that helps you out with this. You should, with a little bit of guidance and a little bit of time, be able to do this entire worksheet. It really, really, really helps if you actually write out the steps that you're following. And then on Monday, we're going to learn how to reverse percent composition calculations. So be prepared for that. Have a great one.